All right, hello everyone. This is the first meeting for the applied stats, or for the CSC people is probability theory, and we'll start with lab 7, which is, I would say, which is the hardest because you have to actually understand the statements. So instead of the slides, I'll start with the absolute basics in Matlab itself. We have this practice plus .mlx file. All right, so if you can see here in Matlab, we have vectors. So we have a vector. Vectors are contained in square brackets, and the information inside a vector can either be separated by space or by commas. We can append vectors to each other like this. This will mean that the values in W are 4, 7, 3, 9, 7, 10, 11. This is how we can address the elements in a vector. And one thing to remember is in MATLAB, indexing starts from 1. So if you want to get the first element in Java you would do 0, but in MATLAB you do 1. So that's something to keep in mind. You can see your second element is 2 and fourth element is 4th. Java it would be 3 and 5. And here is a Boolean statement. If you only want the elements of W which are greater than 5, we do W greater than 5. We can try here. We create a, maybe increase 5. And MATLAB sucks. Okay, whatever. It's not too small, is it? The font size? Oh yeah, one thing I forgot to disable annotation for everyone. Alright, so is the font size too small, or can everybody read it? Hmm, right. Okay, suppose we have a vector that has the values 1, 2, 3, 4, 5, 6, and we want the values. So here's one thing that I've seen way too many people, they panic because they don't see an output. In MATLAB, if you don't put a semicolon at the end, so this guy is asking, can you start with explaining the practice quizzes? The practice quizzes use, especially the first one, I would have started with that, but I've seen way too many people fail on the fundamentals. So I'm going to spend like 10 minutes explaining the fundamentals first. So one common mistake that people make is they forget to put or they put a semicolon at the end. This means you don't get any output. So you can see here the vector, it doesn't give any output because I put a semicolon. If I don't, we're going to get the output of the vector here. So, okay, in the vector, it's not that big of a deal, but if you do a function, for example, if you want to find the standard deviation, suddenly if you put a semicolon, and keep in mind in an exam, you won't have time to think. You will start panicking if you don't see an output. You might just give up on the question. So remember the semicolon. Okay, so that's it for vectors. Hmm. Okay, now matrices. Matrix is another important basic because it's don't worry. Okay, so the person texting me, don't worry, I'm gonna speed run the basics. I'm just going to explain whichever parts of MATLAB are in the quizzes. So how to make a matrix, it's used in labs 9, 10, 11. So this is a vector, right? A matrix is a vector but with different layers. So I have a matrix here. Each row is separated by a semicolon. So suppose you want to make this vector. You have already studied matrices if you're in math. So a matrix is like two, three, four. Suppose this matrix. If you want to make this matrix in MATLAB, you do it like this. Four semicolon, and that's it. That's how you make a matrix. So that's that for matrices. Now this is important for the first question. How do you find a full first row of a matrix? You have to wait. Did my screen sharing just stop? Oh yeah. Yo, hurry. He took back the host. Just turn on screen sharing for people other than hosts.
Wait, I just joined and it stopped. You can start again. I don't know what happened.
Shame on you.
I even disabled the ability for people to unmute themselves. But Hari, you just reset all of the
I
settings.
joined the meeting.
You reclaim the host. Just give me the host again. Okay, so I was explaining matrices. In the meantime, let me just see the next topic. Okay, so I just have to explain how to get an entire row of a matrix. No, and an entire column of a matrix, and that's it. Then we can start the question. Oh, no, I can do it. Also, Hari, disable the ability for people to unmute themselves. Paint, PowerPoint. Okay, so for this matrix, if I want to get the second, this matrix, you can look at it like this as well. There we go. So if I want to get this entire column 2, 5, 8, I can just do this. Well, no. It gets an entire row like this. So I get 5, 6, 7. But yeah, this will be useful in the question. Now, for the first question, I'll just show you the question first. Yeah. You've probably done it in the class. Actually, no, you have to know the meaning of these. So you already know the meaning of mean. Mean is basically the average. STD is standard deviation. And by the way, in the oral exam, he might ask about the meanings of this. Standard deviation is how much I think it deviates from the mean. Median is the middle point of data. And quantile is a part of some given data. Suppose you have this data, right? It goes from 1 to 10. And you want the median is here, right in the middle. This is the median. What if you want the well, you've heard of the word this, it's used in the exam quartile and quantile. So quart means 4. So what does quart what median does is it divides data into two parts, right? What does a quartile does? A quartile divides data into four parts. So it's 3 points, one, two, and three. Now this data is divided into four equal parts. What does quantile does? It divides the data into n different parts. So, a second, let me mute my phone. Okay, so you can say that a median, quantile takes a number of parts. So a median is just quantile with one part. Like you give 0.5 to the quantile, it will draw a line right in the middle of the data and divide it. Quartile means you give it three values. So you pass three values into the another quantile. So the first value, if you want to divide it into uh, four equal parts, this line will be at 5, right? Let's just do it from 0 to 1 because that's more common. 0 to 1 because the quantile takes input in 0 to 1. So the middle line will be at 0.5, right? And then this line will be at 0.75 and the first line will be at 0.25. So if you want to divide a line into four equal parts, you would pass in 0.25, 0.5, 0.75. Basically give it 3 points. Now, this is important because in one question it asks for the upper quartile. Maybe it will ask for the lower quartile. So what if it says the upper quartile? What is the upper quartile? Quartile means four parts. Upper quartile means this part. So if you want to see the upper quartile, you would do quantile. Now you know the purpose of quantile. It divides the line into different parts. And if you only want the upper quartile, you will give it 1 point. And that point will be placed at the upper quartile, so 0.75. If you do this, it will take this part from the data and keep only that. So yeah, keep that in mind. Now, this question is it's something, this conversion especially. So in this exam, according to Sadman himself, there's two conversions that is recommended for you to memorize. The first conversion is the conversion of converting Celsius to okay, one of my teammates just told me that the quartile, the quantile thing, it doesn't give all the data above that part. It only gives the cutoff point. So I'll go over that again. Just this is real quick. Celsius to Fahrenheit and vice versa, and also miles to kilometer and vice versa. So the formula for Celsius to Fahrenheit is very simple. Just check my notes. I also always forget it. So it's Celsius to Fahrenheit is Fahrenheit minus 32 multiplied by 5 by 9. So suppose you have a Fahrenheit value, this Fahrenheit value is anything, and you want to convert it to Celsius, you do Fahrenheit minus 32 multiplied by 5 over 9. This is the equation that you need to remember. Now from this you can easily convert, if you want Fahrenheit instead from Celsius, you can just use algebra. So the 5 over 9 goes there. It's Celsius multiplied by 9 over 5. So it's like Celsius multiplied by 9 over 5 plus 32. Get what I mean? Miles to kilometers is a bit more annoying. You have to memorize 1.6, I think. So there are 1.6 miles in each kilometer. If you want to convert kilometers to miles, you do, you just say 1 kilometer is equal to miles. What is 1 divided by 0? Yeah. So 1 kilometer, no, it's the other way around. 1 kilometer is equal to 0.6 miles. So that's that. 1 mile will be 1.66 kilometers. So this is another conversion you have to remember. And yeah, that's it for conversions. Let me just go through somebody else. So quantiles. So this will not just give all the data. Quantile just looks at 0.75. So this will return 0.75. By the way, this is not how the question is in MATLAB, how the method is in MATLAB. MATLAB, you have to call the quantile function. The first parameter will be the data, and the second parameter will be the points. So Omar asked, what is the difference between quartile and quantile? So it's this R. Quart means 4, and quantile means like the n. So quantile is used to divide a line into any amount of pieces. Quartile is for 4. So if you want a quartile through the quantile function, you will give it 3 points. So you give it point A, point B, and point C. Mhm. Then is asking, so if I write in quantile 0.5, it will be 0.5. Yeah, it will be 0.5. But depending on, like, this line is between, say, this line goes from 1 to 10. Okay, so what if it's a line that goes from 1 to 10 and it is a vector which you save in the data variable? If you go quantile and you pass in the data and you say give the point 0.5, you want it smack dab in the middle, it will give 5. You can check it right now inside Matlab. You have a vector that goes from 1 to 10. By the way, this is the shorthand syntax. It will give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now what if you want, I use the quantile function. First, I have to give in the vector, and then I have to give it the points. Let's start with, I'll divide it in only one point, 0.5, right in the middle. So it should give 5. Let's see. It gives 5.5. Wait, the people here who are good at math, is this correct? The exact middle value between 1 to 10 is 5.5. You know what? Let me go from 0 to 1. Yes, this is the median. You know what? Just to confirm it, I can just find the median. This is supposed to be the median. So let me see if the median, because median has its own function, median of vector. Yeah. So yeah, the exact middle of this data is 5.5, not 5, my bad. Actually, it makes sense, it's 5.5. Yeah. So what if you want to divide it? Let's find the upper quartile of this data. Tane said, so lower quantile is 0.25 and the middle is 0.5 and upper is 0. See, Tane, that's the thing. You can't say lower quantile. You have to say lower quartile. Quartile means four parts. So four parts means we are making 3 points. So you get it? Also, stop directly messaging me. Message in the general chat so they people also see what you're saying. So yeah, you got it. Omar is saying vector is the parameter of the data because we have 1 point. Yeah. So what if you want to make 4 points? We'll give 0.25, 0.5, 0.75. So it's in four. So the first point will be at 3. Second point will be 5.5. 8. By the way, 8 here will be the upper quartile. So what if in a question it says, hmm, okay, let me give an actual example. This is the vector, right? And you need all the values that are lower than the lower quantile, lower quartile. What do you do with that? First, you find the lower quartile, which will be quantile. You pass in the parameter vector, and the point lower quantile to 0.25. This is the lower quartile. Sorry, I keep messing it up as well. Anyway, now all you have to do is find the values which are lesser than the lower uh, quartile. So I think it's vector where, yeah, 1, 2. So you can see, I think the lower, let me print the lower see the lower quartile is 3. So it gives 1 and 2. This, like we did there, it's a Boolean like this. We address the elements of vector which are lower than any value. You could even say lower than 5. It will give 1, 2, 3, 4. Right here, gives 1, 2, 3, 4. So now we get the idea of quantiles and quartiles. Well, you probably do. So I'll move on. Let me look at the notes. Oh yeah, by the way, they might also ask for range. What is range? Range, well, there's a function for range, I think. Yeah, there's a function for range. But in the oral exam, if he asks what is range, range is maximum minus minimum. It's just the highest value in the set minus the lowest value in the set. That's all range is. Now you know how to do matrices. By the way, here when dealing with a data set in MATLAB, you have to import it yourself. In the quiz, they have already done it, so you can display the results. I'll show it later in the quiz. It will make more sense there. This you already know. Mean, standard deviation, median, quantile, range. See here they're dividing it in two places. This is the lower quartile and the upper quartile. Muhammad Amr is asking, do we know what data set will be coming in the exam? Actually, I should probably stop saying people's names. Do we know what data set will be coming in the exam or? Uh, well, we don't already know, but you can tell by the quiz. I'll explain how to read the quiz question. He says all the variables in there. Now, what is Qness? By the way, histogram and QP plot are not coming because, plotting. Skewness is basically for the oral exam. Skewness is the rate of change of a graph. Skew means something is, it's not straight. So skewness is basically rate of change of a graph. Here's this question. A cyclist had a race which had the following time results in four stages: 120 kilometers, 130, 110, 120. What is his average speed kilometers per hour? So here, first thing they did is the time is in minutes. So you got to keep in mind what unit is given in the question and what unit he's asking for in the answer, because he tricks a lot of people like that. So in the question, it's minutes, this is hours. So you divide the times vector by 60. So now you have the length in kilometers and the time in hours. All you have to do is divide the speed by the time. Well, the distance divided by the time, and you have the speed. And this stuff, okay, that's it for the practice plus. Now we look at the actual practice. The miles per gallon thing. You already know how to convert from mile and gallon. And don't worry if you don't remember it. He will always give the conversion factors. Now this question might seem tricky because see, from miles per gallon, miles is a measure of distance and gallon is a measure of volume. Calculate liter per 100 kilometers. So here distance is on top and volume is at the bottom. Now liters, volume is on top and distance is at the bottom. So the first thing they do is flip it over instead of, do 1 divided by something. Maybe I should visualize it. See, miles per gallons. So this is basically distance divided by volume. What they want is liter per 100 kilometers. What this is volume divided by distance. So the unit they want is the complete opposite, which means 1 divided by. Now the period here means it's an element by element operation, which I think it means just actually no, it's not a good explanation. Let me just ask ChatGPT because it always confused me as well. And Sadman told me that a lot of people fail because of this. All right, so the difference between a normal multiplication or a normal process is that it follows the normal rules for algebra, algebraic multiplication, division, stuff like that. The best example would be matrices. Matrix 1, if you have the first row 1, 2, 3, semicolon, 4, 5, 6. This is the first matrix. And then you have another matrix. It goes, I guess, 1, 2, 3, 4, 5, 6. And you want to multiply the two matrices. First, you will multiply the two matrices the normal way, multiply matrix 2, and then you will do element wise, which is what the period means. Period multiply matrix 2. Oh, by the way, matrix multiplication has its own rules. It goes like thing 3 to 3, because these are 2 by 3 matrices. Yeah, 2 by 3, 2 by 3. So it doesn't follow the rules for matrix multiplication. So it should work now. Yeah. So now it multiplies using the matrix multiplication rules. But if we use the element wise multiplication, it should just multiply. See, despite them not following the rules, it just goes ooga booga. One is at the same, 1 multiplies 1, 2 multiplies 2, 3 multiplies 3, 4, 4, 5, 5, 6, 6. So element wise means that it multiplies every single element individually. So that's why 1 divided by this dot is important. Okay, otherwise, all you have to do is miles per gallon. You multiply that with, okay, so before flipping it, let me just explain. So it's miles per gallon, right? And we want that. So first we convert miles per gallon to 100 kilometers. So miles per gallon to 100 kilometers per liter. So going from a gallon to a liter is 1 gallon is 3.79 liters. So we just do miles per gallon multiplied by, and the gallon gets multiplied by 3.79, and the miles get multiplied by 1 mile is 1.61 kilometers. 1.61. Now here it does ask 100 kilometers, which means we multiply the whole thing by 100. You see here. Yeah. Multiply the whole thing by 100. This will get us 100 kilometers per liter. And then, since it is the, other way around, we just flip the whole thing. And you can see here, that's what they do. If anybody has any questions, just type in the chat, otherwise I'll proceed. So this might be important. Rounding, it just takes in a number and it rounds it to this decimal place. Now this is really important for the exam. I would say the most important thing. And this is how to find a specific index in a data set. And here it says, which car has the highest consumption? Use the model character variable to get a name of the car. So now you have to understand how data is stored in Matlab. So suppose each car, right, the car data set has different attributes like the model. there's model, there's consumption, there is, I guess, year. But anyway, it has a whole list of data and it goes like, model, Tesla, consumption 36, year 2003, and all the data. And we can access all the data of a specific index by going, first we have to find the index though. So first we find the model. So you can see here. Nah, first we find the index. So we use the find function returns an index, and this takes in a condition. So we want to find the card that has the highest consumption of these units, and we have that consumption right here. So we do index is equal to find. What is the condition of which we're fighting, which we're finding based on? It is the consumption of that car needs to be equal to the highest consumption in the whole vector here. So this is basically all the consumptions in one vector. And then once we have that index, then we go model, index, and the whole colon. So what this will do is first we find the consumption. For example, this consumption is the highest. It can be like 14, this Tesla, this Ford. So this is the highest, right? So the syntax goes row, colon, when getting something, and we do model. So we are finding the model, which row and which column. So these two basically combine to form a car. So if you do row 0, well, in Matlab, the indexing starts from 1. So row 1 and colon 1. This is basically this whole car. Let me just confirm something. This is the index and all the columns. Actually, I don't think I should be explaining how the database works in detail. So just know that what it does, it finds an index and it finds, the model. It finds the model at that car. So that car is at that index. Yeah, it's being recorded. So at that index, and what this means is you take all of the columns associated with it. So first you find that index and you just take the whole line and you find that model. So this will find the model of that car. Now another thing, this is also coming in the exam, the relative frequency. So it means count the number of cars with the consumption higher than 15 liters. What is the relative frequency? So in the exam, they will use the word called proportion. What is the proportionality of cars with consumption higher than 15 liters? So this some liters per kilometers per hour. This is the amount of cars with the consumption higher than this. To find out of all of the cars, how much of what proportion of cars has the consumption higher than 15 liters, You just divide it by the total amount of cards. So yeah, that's this. Now I'll start explaining the actual quiz, which is the thing I'm prepared for. So yeah, sorry if I stumbled a bit in that explanation. It was important, but I'm not the best person to explain that. Okay, here. Now, the way this works is you have the data in columns. By the way, the reason I said this is wrong is because I think the data is actually stored in columns like this. So the first thing you should do when you go in is confirm the name of the variables by using this command called who. This will show you all the variables that they have already loaded in. There is the city, January temperature, latitude, and longitude. These are the US temps dataset. So the way this dataset is, let's show a representation. It's like city, Jan, temps, latitude. The reason I'm explaining this in detail is because he will change it around. So you have city 1, A, B, C, city D. Temperatures could be like 1, 2, 3, 4. Latitudes, something. Actually, for latitude, I should put in values. So you have random values in each row. Now, what the important thing here is when I look for the like, for this, let me open the code as well. Yeah, this is what if I do a conditional. So what if I do now remember how I said you have to use well, first you have the variable, right? Gentemp. So this is a very important distinction in Matlab. If you do gentemp and then you do lower than 30, this will give all of the temperatures in that vector that are lower than 30. But what if you do, yeah, but what if instead of, using the brackets and the variable name, you just do this, gentemp is lower than 30. This is going to give a bunch of booleans. And this is very important because the size of this vector, okay, I'll show it here. So the size of this vector right now, latitude, is let's say 4. And what if you run this query? Latitude smaller than 77. This will not return a vector of all. What you might be thinking is it's going to return 55, 56. No, it's not going to return that. The resulting vector will also be of length 4. You can store it in a value called lat1, let's say. So I'll put lat1 here. And this will be the same length as this. It will just be Boolean. So 1, 1, 0, 0. So it will go through each value and it will see if it meets the condition. 55 less than 77, yes, so true. 56 true. 77 is not less than 77, so 0, 0. So this is important when we're trying to figure out which values to exclude and which values to use. So why is this important? We can because this is the same length as the original array, as the original vector, we can use it to grab other stuff as well. What if we only want the names of the cities which have a latitude below 77? Since this is of length, is the same length, and the indices of this will be, this is index 1, this is index 2, this is index 3, this is index 4. So all we have to do is get the cities at these indexes. So index 1 and 2. That's why it's the same length as the original. So we can use it to grab any column we want. We want the city, we want the gentemps, we want the latitudes, stuff like that. Anyway, that's the explanation of how the database works. Now we can start solving. Now, how to read the question? You have the variables here. And the first thing you have to do is, let's define the January mean temperatures in Celsius. You can see here January mean temperatures in Fahrenheit. So they're given in Fahrenheit and they're required in Celsius. So first thing you have to do is convert them to Celsius. Yeah. All right. So first thing you have to do is convert it. So for now, just create a new array. Let's just call it, it's in Fahrenheit. We want it in Celsius. So let's do Celsius temps is equal to, so we have Jan temp, right? Jan temp, and here, if you remember the formula, it's Jan temp minus 32 multiplied by 5 divided by 9. Now we have a vector of those temperatures converted to Celsius. Good. What is the next requirement? Let us calculate the upper quartile of the latitude and then work only with those cities whose latitude is lower than the upper quartile calculated earlier. So break it down to smaller pieces. First, let's find the upper quartile. What is the upper quartile point of the latitude vector, here latitude? So we go that, by the way, I'm naming these variables super long because I'm explaining. You can make them shorter in the test if you want. Yeah, Hari, is being recorded. So we do let upper one, and quantiles, you use a quantile function like so. What values do you give into the quantile? You give in the input, which is let, and what points do you want to divide it into? So you only give 1 point, which is the upper quartile, quart 4. So that would be 0.75. Now you can see here it gives the upper quartile, which is 42.65. Now what we want is that Boolean array like 0, 1, 0, 1, which cities have it above, uh, above well, lower than the upper quartile and which don't. So we just go let. So I'll name it lat lower. And this is basically the latitudes lower than the upper quartile. So well, not the latitudes, which indices those latitudes are on. So we will do let, which is the name of that variable, is smaller than let upper was. Yeah, let upper quad. So you can see what it's going to print. 11001110. This is basically going through the latitudes and marking which indices, because as you know here, it's like it's in a rows and columns format like this. So it helps to have those indices. because we can just get anything using those. And we'll actually do that in the next line. Now that we have those latitudes, we'll get the vector of cities. This. So which cities are focused? Cities which have the latitude lower than upper quart. So we'll use the city variable and fit in all those, at the indices. At which indices? These indices. Yeah. So if you want to see which cities are included, we just go city, left, lower. So you can see which cities have their latitude. You can see here. These are the cities. But right now, this is not in our focus. What we want is the temperatures. So how do I see which temperatures in the Celsius temperatures are at these indices? All I have to do is do temps focus is equal to, and I will use that variable Celsius temperatures. Celsius temperatures and which index, this one, lat lower. Not remember. So now you have all the temperatures that are focused. Now, by the way, all of this you can have it in my notes in Telegram, all the code, so you can see the code later. So anyway, now that you have the temperatures in focus, all you have to do is find the first thing, mean. Okay, find the mean of temps focused. That's the mean. The standard deviation, temps focused. What is the proportion? Okay, so now see, what will be the proportion of cities where the average temperature is below freezing? So don't worry, you don't have to find the average. These are already mean temperatures, which means average has already been found. But you have to find the proportion. So proportion is the same as relative frequency, which is first all the temperatures that meet that demand. So sum which temps in, by the way, I'm using temps focused. Temps focused is all the Celsius temperatures of cities which meet our criteria. So a mistake that some people make is they use Celsius temps. But yeah, some temps focused divided by length. By the way, the time is running out, so let me just solve it real quick and then I'll explain. Wait, why the hell is the proportion a negative number? Huh? Okay, I'll probably have to debug that. Hmm. Yeah, let me finish the attempt. Yeah, the only thing wrong is the proportion. If I had more time, I would have been able to debug it. Let me see what I got wrong. Yeah, there you go. That's my problem. So here, what I should have written is temps focus. Let me just copy it all and start a new attempt. Okay, so here's what I did. So I stop here. Oh yeah, temps focus. Lower than 0. Okay. So temps focus is the temperature of all the cities that are in our focus. We find the mean of them first. Then we find the standard deviation of them, which is required here and here. Now, what will be the proportion of the cities where the average temperature is below freezing, which is smaller than 0? So some temps focus lower than 0. This goes through the temperatures in focus, and every time it sees a temperature that is below 0, it counts it. And this is basically the amount of temperatures that are below 0 and in our focus area. And then we divide it with the total amount of temperatures that we are focusing on. So this will give the proportion. It's like if you say, what percentage of computer science students are depressed? There's like 10 total students and 3 of them are depressed. So we will say, what is the proportionality? 3 depressed students divided by 10 total students. And whatever the result is, we can say that that much of computer science students are depressed. So it's like that. This is the proportionality. Now, this is that finding thing I talked about before. So we do find temps focused is equal to max temps focused. So what we have to do is find the index where the temperature focused of that index. So if we go here, suppose 1 and 2 are temperatures focused. So we have to see if the temperatures focused is the same as the maximum of the temperatures focused. So 2. So we go here, okay, at this index, is this temperature is equal to 2? No. Here, yes. So this will give the index of 2. So find will give 2, and we will store that index. Then we will go here, hot city is equal to, by the way, these are just variable names. You don't even have to store them anywhere. You can just name them anything. Like I can do index, and here I'll just do index, and it will work. Here you don't even need to store it. You can just print it. But city is the variable type. You use that variable type with the parentheses. You give it the index, like which row do you want? 1, 2, 3, 4. We want 2, and we put a colon here. We want all of the information in that row. So colon just means this whole row. So this prints Key West, Florida, which is the hottest city. So we go here and we choose Key West. And the other answers as well. The first answer for your own ease, just do this mean. Hmm. Just store these in variables so it shows it on the output. The reason it took so much time to explain this code, by the way, don't worry, this is the easiest question in the whole exam by far. So if you understand this, you should have an easier time on the other questions. So that said, it's important that you understand everything in it. So if you have any questions, just let me know. And just to prove that this is correct, we'll choose okay, key west. What will be the proportion? We see here proportion, standard deviation, probability, mean, probability, and finish attempt, submit all. And yeah, all correct. Oh yeah, some comments. Muhammad Amar. Why is smaller than zero? Can you explain again? And so you can see here, what will be the proportion of the cities where the average temperature is below freezing? Don't get confused by average temperature here. Average is already found, the mean temperatures. We are given average temperatures. All we have to do is see which temperatures are below zero and then compare that to the amount of, the overall amount of temperatures. So that the reason it's zero is because it asks below freezing. Is it clear? Okay, great. Any other questions or I'll end this meeting? All right, so I'll end this meeting and we'll post in the group about when the next meeting starts, whenever this meeting ends processing. But yeah, if there's any tips or anything, I'm not good at math. I'm just, I guess I'm parroting what I learned. So if I made any mistakes or you have any recommendations, let me know and I will do that in the next meeting. Yeah, I'm gonna post the recordings after I'm done with all the meetings. So see you guys in the next one.